Okay, another application we can look at with systems of linear equations and two variables is solving systems involving interest. So think personal finance here. So a few definitions. Interest is the amount of money that we get paid for investing money or money that we end up paying when we borrow money. Principal is the amount borrowed or invested. And then finally, simple interest, we're going to use a simple interest formula here. If you were in a class where you were looking much deeper into personal finance, you would look at other formulas, but simple interest does the trick for us. So simple interest involves interest calculated only on the principal. Okay. The formula that we need to know is I equals PRT. I is the interest. That kind of makes sense. I for interest. P is the principal. Again, makes sense. R is the interest rate, but there is a condition on R. It has to be written as a decimal. So in math class, when we have percentages, we most frequently have to convert them into decimals to include them in different calculations or formulas. And to do that, all you do is move the decimal to the left twice. So drop the percent symbol, move the decimal to the left twice. And then finally, we have T, which is time in years, okay? Now, in a lot of these problems, we're looking at interest that's earned or paid over the course of 1 year. So a lot of times T is just 1. So when T is 1, you're kind of looking at I equals just P times R, okay? The 1 is sort of just melted into the problem. And that's going to be the case for part A down here. Okay, so let's look at this right here. So we're going to look at example 3. It says, write a system modeling the given conditions, solve and relate the answer back to the problem. Okay, so in this case, a bank loaned out $12,000. So remember, we're dealing with a loan versus an investment. It doesn't change the calculation, just that's what we're dealing with is a loan. Part of the money that was loaned at 8%, and part was loaned out at 18%. If the interest received was $1,000 total, how much was loaned at 8%? So we have two very distinct things happening here. We have just how much money was loaned out and then how much money is going to be received in interest. And that's going to become the two equations. Now remember, we're looking for a system that has two equations, two variables. So when we go to do that direct translation part and we assign variables, we have to assign variables to two components or two things in the problem. So let's go ahead and do that, and then we'll talk deeper about the two equations that we get. So we're going to let x, let me go back to the black marker. We're going to let x equal the amount loaned at 8%, and we'll let y equal the amount loaned at 18%. Now, I already told you that when we have percentages, we usually incorporate them into formulas in their decimal form. So to do that, you just move a decimal to the left twice. So we drop the percent symbol on 8%, move the decimal to the left, and we get 0.08. For 18%, we drop the percent symbol, move the decimal to the left twice, and we get 0.18. So just keep that in mind. Now, as for the two equations in our system, the first equation, let's talk about just how much money is being invested. So we know, or not invested, loaned out. So we know $12,000 is being loaned out, and it's being loaned out at two separate interest rates. So the first amount is X dollars at 8%. The second amount is Y dollars at 18%. If we add the dollars X and the dollars Y, it has to equal $12,000. That's how much was initially loaned out. The second thing we need to talk about is the interest that's going to be received. So we're going to receive interest on the X amount. We're also going to be receiving interest on the Y amount. And this is where we need to use that interest formula. Remember, interest is PRT. Okay, P being principal, so principal would be X and principal would be Y. R being the interest rates, 0.08 and 18. And even though this question doesn't specifically say it, we're looking at interest that's going to be received in the course of just 1 year. So we're going to let T equal 1. So what we really have is I equals PRT, but T equals 1. So that's a 1. It looks kind of crazy. So I equals just PR times 1, which is just PR. Okay? So what we need to do is take the principal, multiply it by its interest rate, take the second principal, multiply it by its interest rate. That would calculate the interest received on each portion of this loan, and that has to equal $1,000. So we have 0.08 plus, well, we have 0.08x. I forgot my x. plus 0.18y, and that has to equal $1,000. Okay, so the first equation represents the amount loaned out. The second equation represents the interest received on that loan. Okay, now we could solve this using substitution or elimination. So I think I'm going to solve this one using elimination, and then the second one, part B, we'll do it using substitution. Okay, now to solve a system using the addition or the elimination method, you have to add the two equations. And your goal is when you add those two equations, one of the variables gets eliminated or cancels out. It just cancels to become zero. Okay. So for that to happen, we have to make sure the coefficients on one of those variables end up being opposites of each other. So you pick a variable. In this case, let's say we just arbitrarily pick x. I looked at x and I want to eliminate it. Okay. Well, since the second equation has a coefficient of 0.08 on x, we want to make sure the coefficient on the first x is negative 0.08. That way, when we add, the x's just add up to become zero, and that leaves us with just an equation in one variable. So I'm going to multiply the entire second equation by negative 0.08. Okay? Now, when I do that, the first equation becomes negative 0.08x minus 0.08y. So that's where I'm just multiplying my x and my y by negative 0.08. And then 12,000, let's see, I'm going to do this on a calculator. So if you have a calculator, get it out. So I have 12,000 times negative 0.08, and I get negative 960. So multiply all three terms by negative 0.08. The second equation, we're just going to bring it over. We don't have to do anything to it. So I've got 0.08x plus 0.18y equals 1,000. Okay. Now, when we go to add the two equations, negative 0.08x plus 0.08x just equals 0. So we have eliminated the x. Okay. Now, when we combine the other two columns here, negative 0.08y plus 0.18y should just become 0.1 or 0.10y. I'm just going to simplify it to 0.1. So remember, it's like 0.10. So think negative 8 plus 18 is 10. It's kind of the same thing. So we get 0.10 or 0.1y. Negative 960 plus 1,000 should be 40. Now we need to go ahead and solve for y. In order to do that, we divide both sides by 0.1. 0.1's on the left, cancel, just becomes 1. 1 times y is y. And then 40 divided by 0.1 should be 400. You can double check on your calculator if you don't believe me. So at this point, we have solved and we found a value for y. Remember, y was the amount loaned out at 18%. So we're saying of that $12,000 that was loaned out, 400 of it was loaned out at 18%. So let's use that to figure out how much was loaned out at 8%. So we're going to take that very first equation, x plus y. Let me plug in my computer. We're going to take x plus y, where y is 400, and set that equal to 12,000, and then we'll solve for x. So we have x plus y, which is 400, equals 12,000. We need to get x alone. To do that, we subtract 400. 400 minus itself is 0, leaving just an x. And then 12,000 minus 400 is 11,600. So now we think the remaining $12,000 would be 11,600, and that's what was loaned out at 8%. So we've solved the system here. We could go ahead and say that how much was loaned out at 8% is the question being asked. So we could say 11,600, but let's triple check ourselves. So we want to double check here. So let's go ahead and double check and make sure that these amounts for x and y work in the interest formula as well. So I want to take 0.08, that's the interest rate, times the principal, x, which is 11,600, plus 0.18, that's the interest rate for y, but I'm going to replace y with 400. And we really want this to equal 1,000. So again, if you've got your calculator out, take 11,600 and multiply it by 0.08. That gives us 928. We're going to take 0.18 times 400, and that gives us 72. And we need to make sure that 928 plus 72 really does equal 1,000, and it does. So we've been able to double check our answer. So we were able to solve. We determined that $400 was loaned out at 18%, 11,600 was loaned out at 8%, and we were able to check it against our interest formula as well, or our interest equation. So we would say 11,600 was loaned out at 8%. Okay. So it's a good bit of work. You want to double check yourself. That's always wise. But there you have it. So that is using a system of equations in an application involving interest. Okay, let's look at part B. So Glenn requires, I'm trying to adjust my very small workspace here. Glenn requires $5,000 per year in extra income. Okay. He has $70,000 to invest and can invest in bonds that pay 8%, and then a CD paying 5%. So those are kind of the two options that Glenn has with his $70,000 investment. How much money should be invested in each to realize exactly $5,000 in interest per year? First thing we have to do is assign the two variables in our system. So remember, we're going to have a system of two equations, two variables. Let's figure out what the variables are going to be. You can certainly use X and Y like we did in the previous example, but sometimes you can assign variables that help you remember like what the variables apply to. So let's go ahead and say that we're going to let B equal the amount invested in bonds. So think B for bonds. And remember, that was at 8% or 0.08. And then let's just use CD. We'll just think of CD as a single variable, or if you want, if it's easier, we could just think C for CD. That'll be fine too. Let's do that instead. We'll think C is the amount invested in the CD. That's at 5% or 0.05. Remember, in math, when we have percentages, we convert them to their decimal format to put them into different formulas and equations. Okay, so we've assigned our two variables. We now need to build our two equations. So let's talk about the first equation. The first equation needs to address how much money is being invested. Okay, so if we take the amount that Glenn decides to put in bonds, add it to the amount he decides to put in the CD, we'll have $70,000 total. So we just want to take B plus C equals $70,000. Okay, next we have to address the interest, and we do want to look at earning $5,000 in interest per year. Okay, so remember, we have I equals PRT, but T equals 1. So we get I equals P times R times 1, which is really just I equals PR. Okay, that's because we're looking at 1 year's worth of interest. Okay, so to calculate the interest, you take the principal, which is going to be the amount invested in bonds, B, or the amount invested in a CD, C, multiply it by its interest rate, and then technically multiply it by 1 for 1 year. So the amount in bonds is being invested at 8%, so we're going to get 0.08. So 0.08, the interest rate, times the principal B, times technically 1, plus the CDs invested at 5%, so 0.05, that's the interest rate, times C, the principal, technically times 1, and that needs to equal $5,000 total. So we've now got our two equations, one involving the amount invested, the other involving the interest earned, and we have our two variables B and C. Now we just need to solve the system. Okay, and I told you earlier that I would solve this one using substitution. Okay, it doesn't really matter which method you use for either of these. I just want to show you both. So let's say for this equation here, this top one, let's say we solve this for, let's say we solve it for B. Okay, doesn't matter. We're going to solve for B though. So we want to know what B equals compared to the rest of the equation. Well, in order to get B alone, I need to move the C. So I'm going to subtract C. And that tells me that B equals 70,000 minus C. And that should kind of make sense. If we take the total amount invested C, subtract how much goes into a CD, the leftovers would equal the amount going into the bonds, B. So let's just rewrite the system so that we don't get confused. So the system is now going to be 0.08. I keep forgetting my zero. It's going to be 0.08 times B, but what is B? Remember, B is 70,000 minus C, plus 0.05 C equals 5,000. So we've rewritten this system. We've converted it to an equation in just one variable that we can definitely solve. Okay, so we've got to do some distributing here. So let's see, 0.08 times 70,000, we get what, 5,600? We get 5,600. And then 0.08 times negative C is going to be minus 0.08 C plus 0.05 C equals 5,000. We're just solving a regular old equation at this point. We need to combine like terms. We've got two C terms. We want one C term. So negative 0.08 plus 0.05 is going to be negative 0.03. Use a calculator if you need to prove that to yourself. So we get 5,600 minus 0.03 C equals 5,000. We want to get negative 0.03 C alone. To do that, I subtract 5,600. That leaves me with negative 0.03 C equals negative 600. And then I want to get C alone, so I divide both sides by negative 0.03. And let's see what we get. We get that C is equal to $20,000. Now remember, B and C represent how much money is being invested in each of these accounts. So we're saying, okay, C is $20,000. In order to figure out what B is, we take B plus C, which we know is $20,000, set it equal to $70,000. To get B alone, I subtract the 20,000 from both sides. 20,000 minus 20,000 is 0, and that leaves me with B equaling 50,000. So we have the amount that we think is invested in both of these accounts, so the bonds and the CD. We do want to just really quickly double check this against the interest formula. So I'm kind of running out of room, but I think we can do it. So let's double check. So we want to take the interest formula, which was 0.08 times B, which is 50,000, plus 0.05 times C, which is 20,000. And we want that to equal 5,000 total. So let's see what we get. So 0.08 times 50,000. Well, he's going to earn $4,000 in interest in the bonds if he puts in 50,000. 0.05 times 20,000 is $1,000. So he would earn $1,000 in the amount invested in the CD. And when we add those, it does equal his desired $5,000 in interest. So we're good to go. So ordinarily, let me see if I can squeeze in a T. The question said how much money should be invested in each to realize exactly $5,000 in interest. We would say, let me go to the black one. We would say Glenn should invest 50,000 in bonds and 20,000 in CDs. Okay, so I ran out of room. It got a little scrunched. Hopefully you were able to follow my train of thought. But there you have it. Sometimes you'll see these problems called mixture problems, just kind of that's a generic term for lots of problems that sort of fit the mold. But in this case, we're specifically talking about personal finance, so we'll call them interest problems. So just understand that you need to assign two variables, you need to create two equations, and just be really clear on what those equations are kind of in your head before you start building this system, and then it should be fairly okay.